And we start with a keynote. I'm really great and honored about to be allowed to announce him. I think he's known for many things: security, smartness, being German on time, a German with a sense of humor, and definitely he's known for his knowledge on cross-site scripting and every other thing. I recall that in 2012 in AppSec Germany we had an XSS challenge for a free ticket, and not surprisingly he was the first one to return it. Like, this was not hard. We're like, what? Okay, so I could talk forever about him, but you're here to hear him talking, so please, warm welcome for Mario Heiderich.
Good morning, everybody, and thanks, Marty, for the intro. Am I on screen? Yes, it's looking good. So how are you? All good? Everybody like super awake? Still a bit tired? Excellent, I like that. So my name is Mario, and I'm a researcher. I'm a postdoc at the University in Bochum. I wrote my thesis about cross-site scripting and wanted to kind of try to find a way to create a trusted DOM. That failed, but at least we know that it's not possible now. I have a company in Berlin that's called Q53. We do pen tests. I have been speaking on a couple of conferences, wrote a couple of books, a couple of papers, and currently are busy with maintaining Q53 and the DOM Purify project, which is a JavaScript-only sanitizer, and it's open source, and it's free, and you can check it out if you want to. And this talk today is actually my first keynote, so let's see how this goes. Let's see who's here. Do we have any penetration testers here? Raise your hand if so, because I want to know what kind of audience I have today. Excellent, there's penetration testers. Do we have any developers or defenders? Yes, excellent. Holy sh, wow, that's a lot. Do we have any ISOs or CISOs or something like this? Managers? Yes. Do we have any bug bounty hunters? Not that many, but yes, awesome, cool. Thank you very much. Let's see what we can do to cater some good stuff for you. This talk is supposed to be structured in 4 acts. The first act would be the onboarding, where we kind of talk about what the whole thing is about. Then I'm going to try to present a historic overview on how we actually got where we are right now. Then I would like to kind of formulate a problem statement, because I think there is a problem. And then I want to formulate, or at least propose, a couple of solutions. I'm pretty sure that all of the solutions I'm going to propose are garbage, but at least maybe they get us to think and we can develop something out of that. So let's do the onboarding. The talk is about cross-site scripting, and the talk claims that cross-site scripting is dead, we just don't get it. And I have a question for you. So is this like a cross-site scripting bug? That looks like a typical cross-site scripting attack vector, right? Who agrees that this is like cross-site scripting? No one agrees that this is cross-site scripting. It's not the expected result. Anyhow, of course, it's not an XSS, because what we just saw there is a script injection. We call it cross-site scripting, but it's not cross-site scripting, because neither is there a site nor 2 sites or something that is scripting across those sites. So cross-site scripting in the classical sense is pretty much when you install Google Analytics. That's cross-site scripting, but not the thing that we just saw. Maybe our problem is that we give it the wrong name, but just maybe. And let's not make it too complicated. Let's just call it XSS, because the name is actually quite nice. It goes well off the tongue, and it looks pretty cool as an acronym, which is something. CSER, for example, doesn't, in my opinion. There's 4 kinds of cross-site scripting. We have the reflected cross-site scripting. You put something in the get parameter or in a post field, you send it over and it reflects, and it's not escaped, and then something happens. You have persistent cross-site scripting, which pretty much is stuff that is stored in the database or whatever storage system, and then it reflects on a page whenever you go there. Then we have DOM-based cross-site scripting, which is pretty much the variation where the server is not involved at all, because it's all happening in the browser. And we have mutation cross-site scripting, where something in the layer model actually mutates whatever you send in. You send something in that's harmless, and what comes out is not harmless anymore because somebody decides to change it on the fly. The browser, or the server, or library, or something like this. I mean, it's sort of debatable if these categories make sense, because most of the actual vulnerabilities that you find are a little bit of this, a little bit of that. There was proposals to change that, but this pretty much got stuck because it's nice and simple. So what we would do right now to kind of have a look at what happened in the past and how we got to the point of having a problem in the current days is, let's go back in time and see how it all started. And let's call it like the year 0 back then, when the XSS Miss Miracle happened. And let's call it like the year 0 after XSS. This year 0 after XSS is 1999, and we're going to have a look at this particular year and see what happened there. It's actually 1998. It's somehow not really clear what the year actually was. And the legend has it that there was 3 kings called Host, Scheme, and Port who came and visited baby Brendan I. She was born in an iframe. What he got was a blink architect. No, that's not really true. Not sure where I found this. That's not exactly accurate. But what is accurate, that is Microsoft actually coined the term XSS. They were the first ones to dedicate attention to this particular thing, and that is quite impressive. But they weren't sure how to call it at first. And they were debating about this, and it was supposed to maybe be called unauthorized site scripting or unofficial site scripting, I like this one, or URL parameter script insertion, that's quite specific, or cross-site scripting, or synthesized scripting, or even fraudulent scripting. I sort of like all of these, but you can see cross-site scripting like still goes best off the tongue, just like sounds best. And then I wanted to call it CSS. And then I realized, oh, wait a second, we have that already. Damn it, we have to call it like XSS. That's much better. And there we go, that was it. That's how it happened. Year 99, year 0 after XSS. Soon after, there was a CERT advisory. Maybe you have read it back then, actually. And this was spot on. It was an excellent advisory because they got it right from second one on. Because they said, a website may inadvertently include malicious HTML sheets or script in a dynamically generated page based on unvalidated input from untrustworthy sources. This can be a problem when a web server does not adequately ensure that generated pages are properly encoded to prevent unintended execution of scripts, and when input is not validated to prevent malicious HTML from being presented to the user. That's pretty much it, like nothing else is needed. Just delete all the papers because everything is in this particular paragraph. That's awesome. Very good assessment. And then it took off from there. Back then, in these days, web security was not that huge of a field, and it wasn't as complex as it is today. So people had the possibility to be human genome researchers and at the same time be web security experts, because the part of web security was actually tiny in these years. And Lincoln Steen, an actual human genome researcher from the Cold Spring Harbor Laboratory, wrote a book about web security in which he stated that cross-site scripting allows a bad guy to trick an innocent guy into running code the bad guy wrote. That's also accurate, a little bit shorter, quite accurate. I don't think it's really possible today anymore to be an expert in one field that is super complex and another field that is super complex unless they're a genius, but back then, as mentioned, web security was still pretty little and made baby steps. Then, of course, developers chimed in, and I found this comment in the PHP documentation that I really like from Jake McMahon at hotmail.com. He explains it like this. This function is particularly useful against XSS cross-site scripting minus. XSS makes use of holes in code, whether it be in JavaScript or PHP. XSS often, if not always, uses HTML entities to do its evil deeds. That's kind of not accurate, but anyway. So this function in cooperation with your scripts, particularly search or submitting scripts, is a very useful tool in combating hacksaws. So that was 13 years ago when they documented HTML entities and sort of going the direction of not fully having understand the material, but well. So we had one tool. And the tool that we had was, for example, called HTML entities or HTML special chars. Essentially, what we would do back then was content transformation. Something would come in, and we would have to change it to make sure that it's fine, that it can't do anything bad on the server, and that it can't do anything bad when it comes back and it's being echoed on the client. You would escape things before processing them, for example, with a database, and you would encode things before echoing them. And that should pretty much be it, right? Because that's like case closed, then XSS is gone, technically. Then, in 2002, pretty much year 3 after XSS, a legendary browser was released. And it was Microsoft Internet Explorer 6 Service Pack 2, and the legend was that it actually added the first full-blown cross-site scripting defense, called HTTP-only cookies. Now, the evil attacker who is capable of injecting the scripts and doing bad stuff in the user's browsers cannot steal cookies any much longer. Huge win. Cross-site scripting defeated? No, not really. I mean, it's a nice idea, and it's sort of like a nice gesture, and we still recommend in pen test reports that people should set this particular cookie flag, but does it really do that much? Is it really that useful? I don't think so, because as a pen tester or as an actual attacker, I don't really care about the cookies. There's like so many more fruit hanging on that tree that I can grab. Cookies, I don't really care about. If someone takes the cookies away from me, so freaking what? I just create a login form and ask the user to log in, and it points to evil.com, or whatever I can do. I mean, I can read CSRF tokens, I could do anything. I don't really need cookies. This actually changed just a couple of days ago because I learned that HTTP-only cookies will make sure in a couple of browsers that cookies don't hit the render, and then certain advanced attacks, including Spectre and Meltdown-like attacks, are not possible anymore. There's like a good text on the Chrome bug tracker that explains this, but this is like so unrelated and so abstract that the actual core purpose of HTTP-only cookies are still to be doubtable, but at least we have them and you can lock the cookies away, although this doesn't really give you much. Anyway, people added defense mechanisms. And people also decided that it's time to kind of add a new tool to be able to defeat cross-site scripting, and that would be trust. I always have the feeling when we start talking about trust, then things are already conceptually broken in terms of security. But anyway, the trust that was added back then was again added by Microsoft in Microsoft Internet Explorer. And it was called restricted iframes. Does anyone remember restricted iframes? Because they're kind of like a niche feature, but they're the precursor to sandbox iframes and the core and the main inspiration, in my opinion. With a restricted iframe, you could basically create an iframe and point to anywhere, and you would say security equals restricted as an attribute, and then that particular page loaded in that iframe can't do anything at all because it runs in the untrusted site zone. It can't script, it can't play audio, it can't annoy you, it can't do anything at all. And that already happened in IE5, if I can remember correctly. So that is like an ancient feature. So now we have two tools to fight cross-site scripting and make sure we can kill it. The first one is content transformation, as mentioned already, escaping, encoding, and so on. And the second one would be content restriction. We can now define who and what can do what and where by giving it certain attributes and certain flags, and we can control other people's content that we embed on our page. It's not that simple anymore because sometimes they need this particular feature or that particular feature or like the business model breaks. So this is like not granular enough, but at least we're going in the direction of having two tools that we can choose from. Then people realized that cross-site scripting actually has a lot of potential. This thing that is written there in the headline says like "Igitt Würmer," which is German, it's just like "Eek, worms." And people quickly figure out that with cross-site scripting, you can create actual viruses and worms. JavaScript snippets that propagate themselves from one user to become a persistent XSS, to infect the next user, and to move on from user to user, or to read your address book, and do a lot of things on a website. Because with the script, you can pretty much do whatever. The sky is the limit, and people realized that and built implementations. Worms were created, worms were released, sometimes big ones, sometimes small ones, sometimes experimental, sometimes laboratory worms, and sometimes real-life worms that actually cause a lot of damage, like, for example, the semi-worm. In the year 3 after XSS, there was a documentation about the Advogado virus, which did exactly that. It was running in like an e-commerce platform, and it cost people a lot of money. And it was an XSS worm. Not one of the most well-known ones, but it actually caused a lot of trouble. Then, needless to say, in the year 6 after XSS, there was Sammy's worm, and he unleashed it on MySpace, and I think he took care of MySpace being down for 3 days, and then the FBI raided his home because they took like a photo and found a license plate, and then they correlated the license plate and found his address, and then boom, they went in and swatted him. That was not nice, and he couldn't use a computer afterwards. You should ask him for the story, it's an amazing story. Then in the same year, Wade Alcorn was writing a paper about the cross-site scripting virus and specified what it actually is, what it can do, what the capabilities are, how you fight it, and so on. A little bit of proof of concept. And then afterwards, he started dedicating his time to the Beef project. So he followed that path. And we realized that to kill those worms, we need new tools, because usually those happen in situations when people wanted to have users submit HTML. Like on a wiki page, or in a web mailer where you have HTML emails, or in your profile page or something like this. And needless to say, you can't encode anymore because then the HTML is killed, even if it's just benign HTML, so you need something more complex. And this pretty much marked the dawn of the sanitizers, tools that receive a dirty string of HTML and then give you back a clean string of HTML that you can hopefully safely use on your website, but still allow you to do a lot of formatting and colorful stuff and blinking backgrounds and whatnot. So you need something that kills the bad parts and leaves over the good parts. And that's exactly what the sanitizer does. And it's an extremely hard task because HTML is complex, it grows, it evolves, and you never know if your sanitizer rules today are still going to hold tomorrow. So that sucks a little bit. But people kept building these tools, and there's many of them. I built one myself with DOM Purify, so guilty as charged. But we need to kind of think about how many there actually are. And there's like so many. And how would you be able as a developer to choose the right one? How do you know it's well maintained? How do you know it's actually secure? How do you know it's battle tested? There is HTML Purifier, which is an amazing tool. It's written in PHP, and it's actually well hardened, and the author did a great job. There's Anti-Semi, And I think it became like the OWASP XSS filter project, which is also amazing. I think right now it's maintained by Max Samuel, and it does a great job. There's HTML law, about which I'm not so convinced because it uses regular expression to filter HTML. You can kind of guess where this is going. Then there's WASP HTML or WASH-TML. I'm not really sure how to call it. It's used in Roundcube, and it's complete garbage, I'm sorry. There's XSS that was quite catastrophic in the beginning, but then it was taken over by the WordPress people, and it's gotten a bit better. There's Safe HTML, Sanitized HTML, HTML Sanitizer, HTML-Sanitizer, HTML Space Sanitizer, HTML Rule Sanitizer, and last but not least, Google's Kaha, which has been abandoned. And all these tools are fine, probably in one or the other way, and have flaws in one or the other way. But the biggest flaws of those tools, in my opinion, is that they run on the server side. And how is the server supposed to know how to do good sanitization if the server has no idea what the browser is capable of? I always thought this is a problem, and because of that reason, I created DOM Purify, which is an XSS sanitizer that runs only in the browser, where the action actually happens. Needless to say, in the early years, we had tons of bypasses, but meanwhile, I believe we're pretty stable, so I'm quite happy about that. But as a developer, like, which one are you going to go for? Which one is going to be the filter of your choice? Maybe one that is not even listed here, but it's a hard decision. It's a tough decision, because if you make the wrong decision, then you have a cross-site scripting, and it might get expensive. Here's something that I saw on the SourceForge page of XSS. It hasn't been touched in a while. And it says XSS is an HTML, XHTML filter written in PHP, plus points. It removes all unwanted HTML elements and attributes. How do you know what is wanted and what's not wanted? What is all unwanted? Like, who specifies that? And it does also several checks on attribute values, all right, for JavaScript URIs and these kinds of things. Cases can be used to avoid cross-site scripting, XSS. Note, I don't have time for cases right now. So maybe you want to reevaluate your decision if you chose this particular one. If the maintainer themselves says basically, nah, I just have bigger fish to fry, sorry. So this is nothing that you would want to see about a security tool. Anyhow, all of these filters have been bypassed in the past. Not a single one was not bypassed. Some of them fixed their bypasses. Some of them tried to fix their bypasses and it failed, and they had to kind of fix them again, and then eventually gave up. And some didn't even bother. You would file a ticket, they were like, yeah, whatever, not really. That's kind of not the thing that we do anymore. So it's complex and not always pleasant. So maybe the title slide was wrong. Maybe I kind of did it wrong with the title slide, and maybe XSS is dead, but maybe we do get it, but maybe we're not smart enough because maybe we're not capable of writing a tool that actually kills it, that provides all that we need, proper encoding, proper sanitization, proper trust. Maybe we don't have that yet. Maybe we need to start building this or start developing these things and wonder what we need to do to actually get to the point of really killing cross-site scripting. The tools that we have right now is content transformation, escaping, and encoding. We have content sanitization, tell the bad apart from the good, leave only the good. And content restriction, define who and what can do what and where. And to be quite honest, if you look at those tools, I think you can safely say that they indeed do fix 99.9% of all cases of cross-site scripting and of all use cases. So this is actually quite powerful already, but still seemingly not enough. So we need to think about what other players are there and what other reasons we have why XSS isn't fully dead yet, because it obviously isn't. Well, there's always academia to help. And academia is always busy with writing papers because that's a currency. And I checked in the year 8 after XSS, which is the year 2007, how many papers there have been already about cross-site scripting. And I used Google Scholar and the date filter, and it turns out that there is 1,930 references to documentations, papers, patents, and stuff like this. Almost 2,000, wow. But still, with 2,000 papers in our back, we haven't managed to fix XSS. That's kind of impressive. Not. Then there's, of course, the other kinds of XSS, like all the niche cases and fringe cases. There's like DOM XSS and M XSS and all these things, and MIME type XSS and plugin XSS and Flash XSS and XSS on your hard disk or in your operating system and in your software that is not a website and so on and so on. So maybe all those tools that we have already are not quite yet enough. Maybe we need more to cover those niche cases and to actually kill it with fire. My favorite one is MIME sniffing cross-site scripting. You know, usually if you want to execute JavaScript on a website, you need a little bit of HTML or XHTML or SVG to kind of provide a framework, a scaffold for the whole thing to execute. And HTML needs a proper content type, and the content type needs to be text HTML or something like that. It turns, however, out that browsers don't really care about this, and they just execute something from, I don't know, outer space. So you can, for example, execute JavaScript from a text file. Because the only thing that you have to do is to create a text file and put HTML in there, and then you put it in an iframe, but the iframe is loaded from an EML page, message RFC 822. And then it will execute because Internet Explorer gets confused about the MIME time. So it's like, you know what? I'm just going to render it as HTML just in case. I know it's a text file, but whatever. That still works in latest versions, like version 11 on Windows 10. Try it out. It's amazing. The same goes for application JSON. You can also execute JavaScript from within a JSON file by just directly opening that JSON file. Well, not directly, but what you would do is you would load it in an iframe, and then you would refresh the iframe twice. First, you refresh it with a server-side refresh, and then you refresh it with a client-side refresh, and then IE gets confused. So I don't really know what I'm doing here. So whatever, let's just execute the HTML and be good with it. That's a cool bug. We find this all the time. And there's many other cases like this, still 20 years after, in the year 20 after XSS. Then there's plugin XSS. I love this one. Have you heard about this Adobe Reader bug that was there about like 8 or 9 years ago? You would open a PDF that was somewhere sitting in a web root, and you would open it in your browser with the Adobe plugin installed, and then the only thing you had to do was append a hash and a string to the URL, and then the string equals, and then JavaScript UI and whatever, like alert1. And it was just blindly executed, just so, because they think, someone puts JavaScript in the URI, that probably means that they want to execute it, so let me just do this. Everyone who hosted a PDF on their website back then, everyone had cross-site scripting. And the recommendation that I saw on some of the forums and some of the mailing lists was like, you should better just delete all the PDFs, right? It's like, what? Seriously? Some people have a business model that involves PDFs. You can't delete your PDFs. Delete your browser or your operating system. Same effect. So that wasn't really good. And as you can see, these cases cannot be covered by the tools that we already have, or that we had back then. So we need more. Encoding and sanitization are not enough here. We need stronger tools. We need more granularity. We need decision-making by those tools. They need to look at things and decide whether this can be executed or not. And we need control over what happens and who executes what. We all know probably CSP, but we don't know where it came from, because CSP really came from something else that was called Content Restriction 0.5 by Gervais Markham. And it was born in the year 5 after XSS, so that's quite an early thing. So he realized very early on that what we have in terms of tools is not sufficient, we need something else. And it got more serious in the year 8 after XSS, and it created the tool to fix everything. And as mentioned, that is the Content Security Policy, CSP. I personally am not a fan of CSP. I'm not sure if that's known, but I usually don't recommend it to people who have a complex website with tons of embedded scripts and whatnot, because it's not feasible to implement. But that might be just my personal opinion. However, I think CSP's problem is that it's pretty much like this gun. It shoots in all directions, tries to solve like 10 problems at the same time, but doesn't really solve one problem for sure. And as mentioned, it's incompatible with most websites, or better to say, the websites are incompatible with CSP, especially already existing one. Yes, you can build one right now from the scratch that has one single purpose, and you can put CSP in, you can kind of build it up from the ground, and then eventually it will work, and you have better XSS protection. But try to put CSP on yahoo.com or any portal, like it just doesn't work. Or put it on techcrunch.com, like this website that has like tons of includes and ads and tracking and whatnot, and like it's impossible. Because either you create a whitelist that allows absolutely everything, or you just don't do it at all. It's just not compatible with a website or vice versa. Then there's the problem with CDNs that we figured out at some point. We realized, wait a second, you can have CSP on a well-secured website, but if this website is using a content delivery network, and CSP is whitelisting this content delivery network, then you don't have any CSP protection at all, because all that you have to do is you import a library from that CDN, use it in your injection, and the library bypasses CSP, something like AngularJS. I accomplished like a huge life goal a couple of months ago, because I managed to pardon my French, I managed to get the term shit into the specification, because we did a challenge back then that was called shit at CSP. We wanted to see how many people know about the problem with the CDNs, and turns out many people knew about this. And then the CSP specification actually picked up on that challenge and put it into the specification, so that life goal has been achieved. Anyway, the result of that is oftentimes that people do something that I would refer to as cargo cult CSP. They build huge CSP rules and spend endless amounts of time of kind of putting them together and concatenating whitelists and hosts and this and this and that. And if you, for example, go to facebook.com, Have a look at their headers. Have a look at their CSP. It's ridiculous because they basically have a huge CSP string that is like 546 bytes, and all it does is allow everything. It makes no sense. It's just garbage. I'm sorry. I mean, maybe it goes to the point of being good one day, but not quite yet. So right now, it just wastes bytes and kills the tree. Super expensive to implement. There's a couple of providers who managed to kind of create a good CSP policy, like, for example, Dropbox or GitHub, but it took them ages to do so, and audits and this and this and that, and there's blog posts that document that. So if you really want to go for CSP on an existing complex website, you're going to invest a couple of 7 digits. I think so. It's really expensive. So that's not really the solution yet. So maybe we need even more tools, like we need more stuff, more butter on the bread, and we need more security features for developers to use. We need Sandbox iframe. We know them already. There's just like gazillions of flags meanwhile. We need sub-resource integrity, so make sure that the JavaScript that we're pulling from jQuery is not compromised. We need sub-oranges, which is quite cool, actually. We need permission delegation, trusted types, feature policies, referrer policies, and more headers. I believe that at some point we're going to face the situation of having more headers than actual content in the website because it's so complex. More, and absolutely more. Maybe that helps. Maybe it won't. I have a feeling it won't. So the tools that we have right now are effectively content transformation. We can escape and we can encode. We have content sanitization. We can tell apart the bad from the good and leave only good. And we have content restriction. We can define who and what can do what and where. And we can hope that the trusted instance is actually trustable, that everything works out fine and that there's nothing wrong on those servers and domains that we do trust. Who knows? Usually we trust ajax.googleapis.com. But then they deliver us old versions of AngularJS because they're CD, and they have to. They can't even delete them because they would break the web. So this whole trust thing is crumbly. Maybe the title slide is still wrong. Maybe we're just like forget about XSS technically being dead because we have all the tools, and those tools are good. And as mentioned, we can cover most of the cases, but we just like forget to use them properly. Maybe that's the issue. With content transformation, people just forget to escape and to encode. Yeah, we escape and encode all the time, but in this particular instance, we didn't. Sorry for that, but now we're going to fix it. And there's another one. Or they escape and encode the wrong way, use backslashes to escape HTML, or use entities to escape for SQL queries, or whatever. Just using the wrong tools in the right place. And it's kind of strange. Like, I would expect more from a website maintainer, because you wouldn't expect a car where the maintainer says, like, yeah, sorry, we forgot the seatbelt. So it's just like, our bad. Next time we're going to have one. Like, we can't forget about escaping and encoding. We need to make sure that it either happens automatically and is built into every framework, or probably don't do it at all, because we will forget it at some point. Then we have the content sanitization problem. The sanitizers get bypassed, or the library is outdated, or the wrong flags have been set, and then there's bypasses. Or we have the content restriction, which is like too much work to implement, and we get feedback from clients that basically says, like, yeah, we would really love to implement CSP, but then the advertising doesn't work anymore, and the advertiser says no, and sorry, but it's about money. Like, we don't want to lose money and do so by doing something where we even lose even more money because we need to implement and test this. So money is in the way, and business is in the way, and complexity is in the way. And I think we're kind of slowly getting to the point of being able to formulate a problem statement. Because you can see it's not all peachy dandy. We have a problem here. We have the tools. We know the attacks. We know the problem. We know the impact. But still, we can't fix it. And I wonder why that is. Why is that so? Let's see what the problem could be. We now have pretty much the year 20AX or 19AX. I'm not even really sure which one it is, 1999, 1998. It depends. We have all the research. We have gazillions of papers and gazillions of blog posts. We have all the tools. We know all the tricks, pretty much almost all the tricks. There's always going to be new tricks, but we don't have this kind of golden age of cross-site scripting anymore, where literally every day someone would find something new and put it on Slackers. Like, those days are sadly over, and the amount of new findings is getting scarcer by the day, but still, it's a good thing. We should know, and we actually do know how to kill cross-site scripting, but we just don't do it. And I wonder why that is. Do we not want to? Like, what's the actual reason? Why don't we kill XSS? We have everything we need, all the knowledge, all the tools, and probably even the budget. I think there might be a variety of reasons. I mean, one of the reasons is, of course, that we say, like, yeah, we just forgot to escape and to encode this one time, but we promise it's never going to happen again. Or a reason that we get to hear is, this is a legacy system. We're slowly migrating to the new one. It takes some time, just like a couple of months, and then it's going to be safe. Or, yeah, we don't really have the budget right now. Come on, we're a startup. We depend on funding. Or, yeah, we use a custom code. We don't want to use this stupid framework that does auto-escaping. We use custom code. It's much better because our developer is really smart. Or the advertisers don't like CSP. Or the developer who once wrote this has long left the company, is now selling used cars and can't maintain the code anymore. Could be. But this kind of slowly turns us into something that I refer to as like chief excuse officers. Because we keep finding excuses, we keep finding reasons. We're really good with delivering them. We can't do this because, ooh, that doesn't work for us. Or I was dehydrated when I was writing the code. Or we do something that's even worse. We delegate guilt and responsibility. Oh, that was the intern. Like, look at this. Well, he wrote that code. Like, we didn't check that. Our bad, but well. Or the project lead accepted the risk. Yeah, XSS is fine. It's not that bad. It's too hard to exploit. Or management doesn't grant a security budget, so we can't actually afford to fix XSS. And this kind of lets us to believe that the fish rots from the head down, right? It's always management, it's always the budget, it's always someone else who kind of delegates down to us and kind of tells us what we can do, what we cannot do, and that's what we use as a reason for not just grabbing the problem by the head and fixing it once and for all. Is that true? I don't really think so. I don't really think it's management. I don't really think it's the stinking intern. I think it's us, it's all of us, like the entire room here, except for a couple of people, Jim, for example, it's not him. But it's our fault that we can't fix it. We as a community fail to fix cross-site scripting. And I don't think we even want to fix cross-site scripting. I think we can, but we have to want to, and that's a problem. And that's probably a thing that not only holds for cross-site scripting, but for a couple of other vulnerability patterns as well. We just suck at doing that, in my opinion. And I believe that right now, it's more lucrative for pretty much everybody here in the room to keep things as they are than actually patching things. So I had this conversation when I was at Nalcon in India, and it was quite late, and I was quite drunk, and I went to the bar to have another beer, which was not a wise decision. But anyway, I saw someone and talked to him, and he was like, hey, you're going to do like a talk soon? And I said, yeah, I'm going to do this keynote about XSS and how we can fix it. And he's like, oh, you know what? If we would actually fix cross-site scripting, a lot of people would lose a lot of money. And I was like, holy shit, this is right. You're hitting the nail on the head. That's exactly what's happening. It's true. I would lose a lot of money. Like, who here would lose money if XSS was gone? Gotta be honest. Of course, fewer pen tests, fewer bugs, fewer bug bounties. That would suck if XSS was gone. So why do we want to fix it? We have no intrinsic motivation to do so. I would suffer financially, probably a little bit. I would have to look for something else to do. Probably I would find it in 2 days, but still, it would be negative, it would not be nice. It's all with the money and the budget and the comfort. So now we need to ask ourselves, what do we actually want? Do we as a community really want to fix cross-site scripting and a couple of other bugs as well? Do we really want to solve the topic? Or do we want to keep pretending that we do and tell to our clients, yeah, sure, we are all for fixing these things, absolutely, but we're not because we need more budget. So that's a problem. And it's a problem in our heads, I think. Because what we're doing right now is we're popping alerts for money. And it's a currency. The more bucks, the better. So who here wants to actually fix XSS? Like, who really wants to fix it and get rid of it for once and for all? I'm not really sure. I'm just like this because I really don't know. But that's good. That's a good sign. Had there been fewer hands, I would have just left the stage. But anyway, that's a good sign. So let's see what we can make out of that, because we're closer to having like the problem formulated, but we still need solutions, right? So what are we going to do now? Like, what's next? Like, how can we get out of this misery? How can we get out of this situation? I honestly don't know, but I have a couple of ideas that I want to run through you and see what you think about them, and maybe you can take them and develop them further and do something with them. Or maybe not. Maybe they're really bad, maybe they're so, but let's have a look at them at first before we decide. One question would be, if we want to solve cross-site scripting, do we need more tools? Do we need more CSP, another version, more fine-grained policies? Do we need RTOR or whatever other proposal? Do we need more headers, sec metadata, feature policies? Do we need yet another layer in the stack? Do we need more complexity? I think the idea is that we do, because these things are being worked on, and I'm wondering if we're actually working in the right direction with adding more complexity and more headers and more stuff. I'm not really sure if that's going to do. We should ask ourselves that maybe. Here's something that I found on the Chromium bug tracker when talking about a newly added security feature, and I think it was indeed sec metadata. And it basically says, as this mechanism is simply an additional HTTP header, there's little risk created by shipping it. Other vendors can pick it up over time, or if it turns out to be a bad idea, we can just like drop it without much fanfare. So this is like the level we are right now. Like, we're building something and we just like see maybe that does something or not. We don't really know. Let's see. Let's just find out. And if not, then we delete it again. So whatever. It's like, that's not good. That's not giving me like a good, warm and fuzzy feeling. But anyway, I checked Google Scholar again. It was like, how many papers are there like today about cross-site scripting? It's like 19,500. Like 19,500 papers about cross-site scripting. That helped a lot, right? Well, not really. I even contributed to that because I added 4 or 5, but 20,000 papers is ridiculous. So I think we might kind of not get emotional about the whole topic and just like step back a little bit and look at it with a little more distance and a little more rationality. Because maybe we don't need a new technical approach. Maybe we don't need more budget. Maybe we don't need more this or more that. Maybe we kind of just lack the motivation to actually fix it. Or maybe we should work on that. And the question is, how do we get people to be motivated to fix cross-site scripting? One tool to motivate people is punishment. And that's one of my favorite tools because it usually works. And we use this everywhere in daily life. It's just fighting crime and keeping people from speeding and raising our kids. And like, why not punish developers when they introduce security bugs? Like in the kitty litter the head goes, and then out again. Just like fix it and now you remember, right? Is that a good idea? Punish people? You want to get punished? Anyone wants to get punished? Anyone wants to punish? Doesn't look like it. I expected some hands now, but anyway. Or let's not do the punishment thing. Let's use, for example, gratification. We use this tool then and when with like bonus systems and giving out trophies and badges and awards and candy for good grades. Let's put some candy in the kitty litter, shall we? No. Why not reward developers for producing fewer security bugs through code reviews or stuff like this? Why not actually show them some glory and give them some fame for producing secure software? Why don't we do that? Let's talk about, for example, responsibilities. Let's start tracking down who was the one who introduced the security bug, review the code, find out how it all came together, what kind of knowledge is missing, and why, and then make sure that the same issue doesn't pop up again the next time. How about something like a fix of the month for developers, for like the best security fix that was produced? Let's praise those who fixed the issue and spread how they fixed the issue so people can actually learn from that and adapt those strategies and do something good with it. And slowly get to the point of building up security culture and replace the security nuisance that everybody is annoyed by. Oh, security people again. Let's kind of start building sustainability instead of new complexity. We have enough complexity already. The stack is absurdly complex. Why don't we have XSS fix challenges? Like stop the alert instead of popping it. Why is there no prominent projects that, for example, contain unit test suites or function test suites for XSS testing? Why is there no extra plugins that kind of help us finding these bugs and eliminate them for once and for all? Why is there no DOM XSS regression test suites using Backdriver, Browser Stack, and all these tools that we already have? Why don't we use them for that? Probably a couple of people do, but I don't see any projects that have enough prominence for people to say, oh, this is the one that everybody uses and it's great. It's still missing. It's a gap. And yeah, I mean, this is probably the way to go. Let's show them, but wait a second. We're again putting ourselves in kind of a weird position because we as a community, we're again thinking about how to teach others how to do things right. But it's still us, right? It's still us who caused the problem in the first place, and maybe we should kind of start with ourselves instead. And not talk about others, how we can kind of teach them and educate them and punish them and gratify them. Maybe we should think of ourselves first. And I think what we should do, and maybe I'm completely wrong with it, a couple of people already disagreed strongly, maybe we should just like stop the bug fetish. We're like fetishizing the bug like so much. We keep praising the bug hunters, but we ignore those who do the dirty work afterwards. I'm not against praising bug hunters, don't get me wrong. I'm only against having an imbalance between the praise of the hunters and the lack of praise for those who actually fix the bugs, because that's the hard work. Only few distros and few software projects actually do this. They actually name the person who fixed the bug. You see this very, very rarely. And our entire mindset is around bugs and not around the fixes. And I think that's a problem. Maybe not for everybody, but at least for some. Yeah. Maybe we should have fix bounties, not bug bounties. And we have them, but they're not really popular. I think NCC and Google sort of do it already, and there was like blog posts, but this doesn't really have much traction. I wanted to find out how popular these things are and check the search engines, and I searched for like bug bounty program, and I got 431,000 hits for bug bounty programs. And then I checked for fix bounty and patch bounty, and I got 2,000 hits. This is ridiculous. So it has no prominence at all. We keep glorifying the finder, but not the fixer. And we don't incentivize the people who fix the bugs to do the dirty work. And I think that's a problem. The glorification goes overboard. We have like interviews with legendary bug hunters. Really? We have media campaigns for bugs to raise awareness, like Badlock and all these things, and eFail. I mean, sure, this has benefits, but are we overdoing this? We're self-proclaimed super hackers and experts and charlatans. You know who I'm talking about. We have top lists, halls of fame, award ceremonies, audience with the Pope, like everything for the bug hunter. What about the fixer? What about the developers? Why don't we do it here? And I think we should like stop doing that. Or at least keep it balanced and give those who fix the issues and who teach those who not have these issues again, give them some glory as well. Why not? It doesn't hurt. Here was someone who really, really strongly disagreed with that statement of mine. It's like, doctor, please, what are you saying? The fixer has a monthly salary and should be praised. Do the work he didn't do while developing the buggy software? No way. Sometimes the finer bug hunter sent information. So people don't like the idea in all places. But anyway, I commented on that. And I don't think we have a working solution yet to all these problems that I just outlined here. And I think that the solutions that I try to present, or at least like the approaches, might or might not work. But we could at least try it, or try thinking about this, or try taking it from there. And I think if we at least get to the point of realizing what and who the actual problem is in this particular market, then we have a chance to get to the point of being able to solve it and to fix it. If we don't do this, then we're never going to fix it. Then there's going to be popping the alert in 15 years from now on, and we're still going to do the very same thing, pop the alert for money. Not sure if everybody wants to do this. I don't want to do this. I want to sit in a house in southern France and look at the beach. But anyway, so I think what we need to do is we need to start being honest. We need to either tell ourselves and others, we don't want to fix it. We don't care about the fixes. We want to keep popping the alert for money. We want to get a good budget with that. And I'm not even judging here. I'm just saying, like, if we are in this particular position, we should be honest with ourselves, and we should be honest with our clients, and most importantly, with the users out there, because they're the one at risk. And I do think if you're in this position, again, not judging, if you're in this position, you should probably rethink your business model, because other people will come and actually fix it at some point, because they will then have the right mindset, and then your business model floats away, and then what are you going to do? You need to think about something new anyway. Or the alternative, we do want to fix it. And if so, and if you are in this position, if you think that this is the thing that we should do, then I would say interesting. Let's discuss how. Let's start like a panel. Let's talk about how we can actually do this. And let's start very, very low. Let's start with the mindset. Let's start with the motivation. Let's start with the incentives. Use Occam's razor, identify the actual obstacle, and create new post-XSS security business models, because they exist. We just need to kind of invent them and come up with them and develop them. We don't have to right now because everything is in place and everything's cozy, but maybe we should at some point, because at some point there's enough people who really want to solve the problem, and then it's gone, and we need to kind of find new ways to incentivize our work anyway. So why not do it now? And I think we can now finally reach the actual title slide that does make sense, and we can say cross-site scripting is dead. But we just need to accept it. We need to accept it for ourselves as a community, as fixers, as bug bounty hunters, as browser developers, as the people who have the budget. And we need to work in this particular direction. Or, as mentioned, be honest and say, like, nope, I'm not interested. I want to keep things as they are. I want to keep the status quo. And this is the branch, or this is like pretty much the choice that we have to make in which direction we want to go here. And now I think we are in a very good position of actually just like doing it. I mean, we are here at this conference with all these awesome people. So we can now get together, we can stick our heads together, we can think about the problem, we can think if we're part of the problem, and then we can develop solutions over lots of beers, how to actually fix this. And maybe next year, we're going to be able to talk about something more positive already, and we're going to have actual progress. And I would be happy if that was the case. And that's it. That's my keynote. Thank you very much.
I expected a great keynote. He promised me a great keynote, and he made a great keynote. Thank you, Mario. Unfortunately, he will not stay with us to the end of the conference for schedule problems. If you have questions, please just come forward in the middle so we can quickly go as many questions as we have. Any questions, please come forward. Not all at once.
You can also be angry with me on Twitter. People did this already. I'm used to it. So.
Nobody dares.
All right, cool. I take this as a good sign. There's a question.
Hi, thank you for an amazing talk. What are your thoughts on a security policy, like a manifest? Because the headers, sometimes the policies are really large. would it be helpful to just say, here's the report URI of the policy, and by the way, here's the manifest of what the policy actually says, so then you can make more complex ones, and for large sites that may have some legacy pages, I'd like a different policy for those so they don't impact the rest of the pages and everything else.
That could work. I mean, making the complexity more simple and more graspable, that's certainly a good approach. And I think the feature policy thing is actually going in this particular direction. Or the possibility where you have like the allow attribute for iframes and these things. So it's an interesting approach. Still, we would try to solve it with technology and not go deeper, but I think that might be one viable way, actually. Yeah.
Thank you.
At least we would take out the complexity, which is good.
Yeah.
More questions?
Yes,
All the way
please.
in the back.
Hey, Mario, great talk.
Thank you.
Mario, as content security policy becomes more common, I'm running into teams where they're not doing any kind of traditional escaping validation, JSON proper usage, JavaScript proper usage, et cetera, and they're just throwing up content security policy and calling it a day. Do you think this is an acceptable defensive strategy?
I don't think so, because as mentioned, there's too many systematic bypasses. If you allow CDNs, then you probably have a bypass already, unless you really specify the path. If you still have users who use IE, well, IE doesn't support CSP, will never. People say IE is dead, but I think it's not, because in the corporate field and in the government field and in pharma and a couple of other branches, it's still very much alive. I went to a client the other day that was this year in February, and they gave me a product demo, and then they fired up IE8. What the fuck, IE8, seriously? And yeah, it works really great in IE8. It's like, okay, so you use IE8 internally. So they would not exactly benefit from that particular way of doing it. Maybe in 10 years, but I think we can do more in these 10 years. Thank you.
Okay, then again, thank you, Mario.
Thank you.